Here we are going to do the CBE1 practice test. Again, you can take the test as many times as you want. You have to get at least 9 on all of the tests in order to pass the class. Otherwise, you get a D, even if you have like 85% or 90% in the class. I don't know. It doesn't make any sense to me, but those are the rules. You cannot use notes. You cannot use a graphing calculator. You can use a scientific calculator. Any other questions? Yeah, you can use the ones on the wall. I have lots of them. Okay, what is the number I? It is the square root of -1. And we refer to it as an imaginary number, not because it's fake, but because it is not on the real number line. So if it's not real, it must be imaginary, right? When we put imaginary numbers and real numbers together like that, we call those complex numbers. And actually, all real and all imaginary numbers are technically complex numbers, right? It's kind of like saying all humans are mammals and all mammals are animals, right? So you have real numbers, which would be like humans, then you have imaginary numbers, which would be like mammals. They fit inside each other. Anyway, whatever. Okay, so if I had x squared equals -9 and I took the square root, I would get x equals plus or minus 3i. Where does that come from? Well, the square root of 9 is 3, and the square root of -1 is I. Okay? What about I to the second? What would that equal? Well, that would be the square root of -1 squared. And those cancel, and I squared is just -1. What about I to the third? Well, that would be I squared times I. And I squared is -1, and I is the square root of -1, so this would just be -I. What about I to the fourth? So I to the fourth would be I squared times I squared. -1 times -1 would just be 1. So I is I squared is -1, I to the third is -I, and I to the fourth is 1. What about I to the fifth? I to the fifth is just I squared times I to the third. So if I multiply those together, I just get I. What about I to the sixth? It's going to be -1. It's I squared times I squared times I squared. So which would be -1, and I to the seventh is going to be -I, and then I to the eighth is just going to be 1, and it repeats over and over and over and over. Okay, so what would I to the 7,481 be? Well, it doesn't matter how many times I go through this list of 4. All I really need to know is the remainder. So does 4 go into 81 evenly? No. It would go into 80, remainder 1. So this is going to be exactly the same as I to the first, which is just I. Okay? If I had I to the 5,750, let's do 54. What is the remainder of 54 when you divide by 4? 4 goes into 52, so it would be some number remainder 2. So this is exactly the same thing as I squared, which is -1. Okay? All right, so that's just a really quick review on I's. Now, when you are performing operations on i's, just like square roots, you are not allowed to leave an I in the denominator. Okay. So first, we need a common denominator. We have two fractions. I need a common denominator. What will the common denominator be? 5 minus 2i. So this needs a 5 minus 2i over 5 minus 2i, which gives me negative 5i plus 2i squared plus 6 minus 3i all over 5 minus 2i. Any questions there? So i's can always be simplified down to either a negative or a number or I to the first. So anytime you have an I with an exponent bigger than 1, you can always simplify it down using that pattern that we just reviewed. So this is really negative 1, which turns this into negative 2. So in the numerator, those two become negative 8i, and these two become 4. I think I did that right. Okay. Any questions so far? Now what? I've got to get the I out of the denominator. Why? It's kind of like simplifying fractions. There are an infinite number of ways to represent 1/2. But if I require all of you to simplify it down to so there's no common factor between the numerator and the denominator, that guarantees that all of us get the same looking answer. So we employ rules like that to square roots and i's, just so everybody gets the same answer. It's in its simplest form. So how do we get rid of an I in a denominator? Well, I can multiply the top and the bottom by any number I want, as long as it's the same number. So I could multiply it by 6 over 6, because 6 over 6 is just 1, and multiplying by 1 does not change anything. But that's not going to get rid of any i's. So what if I multiplied by I? Well, this would become I squared, which will simplify, but now I've just moved the I to the other side. So that's not going to work. We have to do a little bit of a trick. Any idea what it is? Anybody know? Yes. Multiply by the conjugate of the denominator. What is a conjugate? If I have x minus 3, what is its conjugate? X plus 3. And these are really easy to multiply together. What happens when you multiply conjugates? You get x squared minus 3x plus 3x minus 9, and those cancel every single time. Okay? And we're going to use that property to simplify the denominator. So I multiply the bottom by 5 plus 2i. Good job, Ellie. And the top's going to be kind of complicated. We get 20 plus 8i minus 40i minus 16i squared. But what is negative 16i squared really? It's really just plus 16. Okay? And then the bottom, that becomes 25. And then what's going to happen here and here? They're going to cancel out because they are conjugates. And that happens every single time you multiply conjugates together. So you can write them down if you want, but they really just blow up and go away. But this one is negative 4i squared, which is actually just plus 4. And now we have no i's in the denominator. So the method here is use common denominator to simplify it down to one fraction, and then multiply the bottom by its conjugate to get rid of the i's. the numerator becomes 36 minus 36i over 31. 32i, thank you. Over 29. Does that simplify at all? No, 29 is prime. What if it was a 16? Can I take a 16 out of everything? No, but I can take out a 2 or a 4. So pull a 4 out of everything and we would get 9 minus 8i over 8. No, over 4. Make sense? Okay. Let's do... Oh, sorry. Yes. Oh, good. Thank you. So we had 36 minus 32i over 29. So how would I split this into two fractions? It would just be 36 over 29 and 32 over 29. Oh, and this one would have to be negative. Good catch. Thank you. So those are the same, right? We've just separated the fraction into its two halves. Okay. All right, true or false? The imaginary number, the square root of 2i, and notice that I is not inside the square root. So really that's, I would prefer to write it as I root 2, is a solution to the equation x to the 4th plus 4. How would you check it? Just plug it in. So we have I square root 2 to the 4th plus 4, and see if that equals 0. Okay. Well, what is I to the 4th? 1. And then what is the square root of 2 to the 4th? That would be the square root of 2 squared would be 2. And square that, you would get 4. Or you could write this out 4 times. This is a 2 and this is a 2. So I get positive 4 plus 4. Is that equal to 0? No. Okay. What if it said minus right here? Then we would get 4 minus 4, which would be 0. So yes, that would be a solution. Now, these tests are auto-graded, and the entry system is really weird. So the only correct answer here would be a capital F. If you put a lowercase f, it will mark it wrong. Now, I do have the ability to go through and change your scores if something weird like that happens, because last year there were, I don't know, maybe half a dozen times where, as far as I could tell, the correct answer was put in. It just didn't grade it correctly. Or anyway, there were weird things like that that happened. So if you get a question wrong and you think you got it right, come see me and I'll check it, and then I can change the score if I need to. Okay? All right. All right. We need to find out, when does this equation equal 2? Well, I need to multiply it out. X squared plus 12x plus 32 equals 2. Can you guys do those in your head now? You've been working on it for years. Subtract the 2. X squared plus 12x plus 30. Are there factors of 30 that add to be 12? No. So we either have to use the quadratic formula or we complete the square. So I'll show you quadratic formula. If you know how to complete the square, Go ahead and use it. What's up? Okay. All right. So negative b plus or minus the square root of b squared minus 4ac over 2a. Negative 12 plus or minus the square root of 144 minus 120. Is that right? 120 over 2. So that becomes negative 12 plus or minus the square root of 24 over 2. Can I divide everything by 2? Not yet. That root 24 is not actually a 24. It's the square root of 24. So I need to take 24 and factor it down. That would be 2 times 2 times 2 times 3. Can I pull anything out? So I pull out a set of 2's. Why does that work? Anybody know? 24 is really the square root of 4 times the square root of 6. And this is a perfect square. So we're just taking out the perfect squares. So if I had the square root of 72, that is the square root of 36 times the square root of 2, which would be 6 root 2. If I had 75, that's 25 times 3, so that would be 5 root 3. So all we're really doing when we factor square roots and pull out pairs is we're taking out all of the perfect squares and then leaving the leftover inside. So this is negative 12 plus or minus 2 root 6 over 2. Cut that in half. And we get negative 6 plus or minus root 6. So it says put the answers in exact form and separate with commas. So you would do negative 6 plus root 6, comma, negative 6 minus root 6. Got it? Okay. All right. Determine the real number solutions. We've done this already this year. First off, what is x not allowed to equal? So this one factors into x minus 2 and x plus 2. So x cannot be 2 or negative 2. So if one or both of the answers appear in that list, we have to throw them away. Okay. Now we need a common denominator. What is the common denominator going to be? It's going to be x squared minus 4. We need an x minus 2 and an x plus 2. What does this need? X plus 2 over x plus 2. What does the 1 need? It needs an x minus 2 and an x plus 2. And those put together would be x squared minus 4. Okay. On top, that gives me 2x squared plus 4x minus 9 equals x squared minus 4. What about the denominator? The denominator is x squared minus 4, but everything has the same denominator, so I can just throw it away. Right? If all the numbers in a list are divided by 3, then I didn't say that very well. If you took an equation and everything had a 3 in the denominator, you could eliminate the 3's and the equation is still true. So I'm going to throw that away, and remember this is my original restriction. So subtract x squared and add 4, and I get x squared plus 4x minus 5, which is x plus 5 and x minus 1. So x is negative 5 or 1. Are any of those in the domain restriction? No. So they're both answers. Okay. Any questions? Hallie, you all right? So 2x squared minus x, and then the 4x is there, and then I'm going to add 4 here. So I just simplified the equation. I skipped a whole bunch of steps. And then, so this is my equation, and then we factor it and find the roots. Okay. The tests are not timed, but you do have to do them in one sitting. So, I mean, you could take all day if you wanted to, but you just can't. You can't leave. You can take these as many times as you want. Yep. Yeah. I changed the passwords. Yeah. So yeah. Or you can do them in the homework class. You have to take them supervised by somebody, not your mom. All right. So we have a big, long equation, and we want to know what are the roots. So first we have to ask, are there any domain restrictions? Yes. This cannot be negative. So 4x plus 3 must be greater than or equal to 0. So subtract 3 and divide by 4. X must be greater than or equal to negative 3/4. So any value that does not fit in there is automatically thrown away. Okay? And then we just need to find the roots of those. So let's check the first one. Does it factor 3x squared negative 2? That would be 6x squared. Are there factors of 6 that add to be 2? No. Which means quadratic formula. Okay, let's try this one. 25x squared and 4. That would be 100x squared. Are there factors of 100 that add to be negative 20? So 1 and 100, 2 and 50, 3 doesn't work, 4 and 25. Oh, how about 10 and 10? They're both negative. So negative 10x, negative 10x. Pull out a 5x, and we get 5x minus 2 and 5x minus 2. That's a duplicate root. Does it want me to put it twice? That's a good question. We'll find out here in a second. So x is, add the 2, divide the 5, x is 2/5. Is that an acceptable solution? Yes, because it's greater than negative 3/4. If it was less than that, then we would throw it away. Okay. We need to do a quadratic formula here. Negative 2 plus or minus the square root of 4 minus 4 times 3 is 12 times negative 2 is plus 24 over 6. Did I do that right? What did I mess up? Do you have a question? Oh, you got it? Okay. All right. Negative 2 plus or minus the square root of 28 over 6. Sorry, I'm going really fast. You got it? Okay. This is 2 times 2 times 7. So I can bring out a 2, and I get negative 2 plus or minus 2 root 7 over 6. Can I simplify that? Yes. pull a 2 out of everything. Negative 1 plus or minus root 7 over 3. Now, are those answers acceptable? I don't know. We got to find out what the decimal equivalents are. So, negative 1 plus root 7. Oh, wow, that was nice. And then I will divide that by 3, and I get 0.54. Is that an acceptable answer? Yes. Okay, let's try the other one. Negative 1 minus the square root of 7, and then divide that answer by 3, and I get negative 1.21. Is that an acceptable answer? No. This does not fit in there. Okay. Oh, I overlooked one thing. So I know one of my answers is 2/5. I know one of my answers is negative 1 plus root 7 over 3. And there's one more. Yeah. So if this parenthesis equals 0, then it's going to smash everything else. If this set equals 0, it's going to smash anything else. But if this equals 0, it is also going to make the equation 0. So when will this equal 0? At negative 3/4. So negative 3/4 is also a solution. Because when does the square root of 4x plus 3 equal 0? Well, if you square both sides, you get 4x plus 3 equals 0. Subtract the 3, divide the 4. So x equals negative 3/4 is a root. So you need to find the roots of each piece, and you need to check them against this. So they have to be a root of one of those, and they have to fit inside that window. Anything outside that window is not a solution. Questions? It could. It could have no answers, right? If the original problem said x is greater than 10, do any of these fit the x is greater than 10 scenario? No. So they all get thrown out. Well, I guess this one would still have a 10, but yeah. Other questions? So it's not as hard as it looks on your faces right now. So you know how to find the roots there, no problem. You know how to find the roots there, no problem. The root here, you just set the inside equal to 0, so that's no problem. But we know that the domain, this has a domain restriction, and x must be greater than or equal to negative 3/4 by setting that stuff on the inside greater than or equal to 0. So once you have all of your answers, you just test them against this requirement. If they're in, you keep them. If they're out, you throw them away. Now, there were actually 2 copies of 2/5. So let's see if it wants you to write both of them, because I don't remember. So, so 2/5, negative 3/4. I believe it wants the negatives out front. We'll find out here in a second. Like I said, there are some weird things that happen. And then what was the other one? Negative 1 plus the square root of 7 over 3. Thank you. I'll just give up. Yeah. So notice it only had one copy of 2/5, so you don't need to list it twice. And did I do that wrong? Let me add that up again. My batteries are low, so -1 minus the square root of 7. Oops. -1.21. So let's just double check. Let's stick this in here and see if we get a negative number. Wait. Okay, so notice it says real solutions. So if we end up with an I, that should not be an answer. So 4 times -1 minus 7 over 3 plus 3. So 4 times -1 minus the square root of 7 divided by 3 plus 3. I get -1.86, so this is a mistake. Now, there are more mistakes on the practice than there are on the actual test. They've cleaned the tests up quite a bit. But this is one of those instances where I put in the right answer and it graded it incorrectly. So if you think you got it right, come see me and we'll double check. So I could go in after the test and I could add 1 point to your score. Okay. Yeah, it's a little bit infuriating. And hopefully they fixed it, but there are weird things like if you put the negative there instead of there, sometimes that gets marked wrong. I know, it's the math department in Logan. Yeah. So this is not, most computer graded things are done really well, but they're a company that is made up of programmers who build the stuff. And what they're trying to do here is they are trying to use something that is not meant to grade math and grade math. So there are lots of mistakes in it. And hopefully they fixed most of them. And there are more mistakes on the practices than there were on the actual tests. So don't let that frustrate you. I know it really is infuriating, but I can't fix it. All I can do is give you credit if you got it right. Okay, next. This is x to the 4th plus 4x squared minus 21. How does that factor? X squared minus 3x, or 3, and x squared plus 7. Does everybody follow? Yeah? Anybody confused? All right. So there are two ways to do this. So if it was x squared plus 4x minus 21, we would say x plus 7 and x minus 3. So if this is a 4 and that's a 2, then it's going to factor the same way. It'll just have x squared instead. Okay. So if I had x squared minus 9, that would factor into x plus 3 and x minus 3, right? But what if I had x squared plus 9? How would that factor? X plus 3i and x minus 3i. Right? There's no way to use real numbers and multiply to get a 9 and add to be 0. So if you use imaginary numbers, it works because that is negative 9i squared, but I squared is negative 1, and that changes the minus to a plus. Okay? So we have the same idea going on here, but 3 and 7 are not perfect squares. So we just square root it and call it good. So this one is going to be x minus root 3 and x plus root 3. You guys get that? What's the other one going to be? X minus something and x plus something. Well, it has to have a root 7 in it. But is negative root 7 times positive root 7 equal to positive 7? No. So we need i's. So what is the solution set? Root 3, negative root 3, I root 7, negative I root 7. Does that make sense? Do you want to see another one of those? Yeah? Let's see if I can make one. Oh, no, let's not do that. Let's do, there we go. So that's going to be x squared minus 9 and x squared plus 4. Everybody follow? X minus 3, x plus 3, x minus 2i, x plus 2i. Did that one make more sense? Okay, so let's change it, make it a little bit harder. Like this. How does that factor? X squared minus 7 and x squared plus 5. Okay, how does the x squared minus 7 factor? X minus root 7 and x plus root 7. And the next one? X minus I root 5 and x plus I root 5. So my answers would be root 7, negative root 7, I root 5, and negative I root 5. So that's actually one of the easier problems once you see the patterns. Okay. What is the domain? It's just going to be all of the x's. Now, be careful on your Chromebooks if you're zoomed in wrong. Last year we had some kids that couldn't see the whole problem, and they didn't see the little bar at the bottom that needed to scroll. So the domain in this case will be negative 9, negative 7, negative 5, negative 3, negative 2, negative 1, and 0. If a number's listed twice, don't put it twice, just put it once. Okay? Easy enough? Okay. What is going on there? Have you ever seen one of these? So this is called a piecewise function. Well, it's not as bad as you think. So what's going on here is you have multiple graphs that are graphed at the same time, and we're cutting it into pieces. So maybe we take this much of that one. And then we take, anyway, that's not going to work. So you take part of one graph, and then part of another graph, and then part of another graph. And it is a function because it passes the vertical line test, even though it's built out of 3 other functions. None of them overlap vertically. Does that make sense? So if I wanted to plug in, what is x equals -2? So I'd go to -2, and I'd have to figure out which graph to use, and I would use this one. So the answer would be like -3. If I said, what happens when x equals -7? Well, I'd have to go over here to x equals -7 and figure out which equation it was, and then plug it in, and I could get y equals 12 or something like that. Okay? So this says, what is the domain? Well, they told you what the domain is. It's all of this. We just have to transfer it into interval notation. Okay? So I'm going to draw a number line, and I'm going to put each domain on there, and then we're going to turn it into interval notation. So from -5 to -2, I have a closed circle and an open circle. Everybody good? At x equals 2, I have a closed circle from here. And then at 4, I have an open circle. And again at 6, I have an open circle in between. Now, equal to is a closed circle. Yeah, they're all open circles except the equals are closed. Okay? So now, we do interval notation using brackets and parentheses, some copy of that. We just have to choose the left and the right of each version. So, brackets are closed circles, and parentheses are open circles. So, this piece here would be bracket -5, comma, -2 parentheses. Okay? And then I bet you put comma, and then just the number 2. Nothing around it, just 2. Comma. And then this one goes from 4 to 6, and they're both open. Now, let's try that. Well, yeah, that's what we usually do, but they are probably going to have you put a comma. That's my guess. Let's check. Oh, there is a union. Okay. So this, and we will put -5, comma, -2, and then go outside union. Good call. Union with the number 2. Ooh, is it going to want brackets? It might. We'll see here in a second. And then this one. Did it? Yeah, so should I put brackets around that? I don't know. I'm about to find out. Come on. All right, let's see. Try again. So that's not even the right symbol. Oh. Well, I could just use my keyboard. Let's see if that does it. Okay. Can you remember that? And this was not on my little keyboard. Right? It's not there. Those are different. Group in curly braces. Yeah, don't use this one. Okay. All right. Next problem. Use interval notation to describe this. What domain restrictions is that going to have? Well, 9x minus 1 cannot be 0, and 4x plus 3 must be greater than or equal to 0. Everybody understand that? The square root cannot be negative, and the denominator cannot be 0. So x cannot be 1/9, and x must be greater than or equal to negative 3/4. We have to piece that together. So on the number line, negative 3/4, closed circle, shade to the right, but I have an open circle at 1/9. So how would I describe that using interval notation? So negative 3/4 with a bracket to 1/9, union with 1/9 to infinity, and infinity always gets a parenthesis. We can never equal infinity, so it always gets a parenthesis, not a bracket. Okay. What if it was the other way around? What if we had the square root of 4x plus 3 in the denominator? How does that change things? It can no longer equal 0. So if you have a square root in the denominator, you do need to do this to guarantee that it's not negative, but this goes away because if you equal 0, then the square root of 0 is 0. So you just throw out the equal to. Okay. Oh, this is tough. F of 2. You're just going to stick 2 in there and see what it equals. Piece of cake. What about f of x plus h? We're going to do this. So that is 8 times x squared plus 2hx plus h squared plus 5x plus 5h minus 2. Oh. Sorry, I went really fast again. So x plus h times x plus h, x squared, hx, hx, h squared. Oh yeah, thank you. So 8x squared plus 16 hx plus 8h squared plus, oh, none of it goes together. There are no like terms. Yeah, so it doesn't simplify beyond that. Yep, this is the result. I don't think it, oh, the order shouldn't matter. I don't ever remember that being a problem. But if it does, come see me. I'll fix it. Why won't it let me? Did I do them all? So, okay, so question 5, 6, 7, 8. I feel like I'm missing some. Yeah. All right, so we did that one. So 2, 3, 4. Does it feel like we did 10? 5, 6, 7, 8, 9, 10. Okay. All right. So for the rest of today, you can work on the practice tests. So you're going to log into your USU account with your A number, and then you will automatically be logged into their Canvas. And so you'll go into Canvas and go to Assignments and do Practice 1.